The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Good morning, everybody. I'd like to thank everybody for attending. We get started, I'd like to thank my co-author on this presentation, Kevin Paul. He's also a project manager with CVM. And it's also great to be giving a presentation in the same room as Avanti, who is really the sort of the grandfather of the ACI Concrete Repair Code. He had a vision 30 years ago. It didn't quite make it to fruition, but he had the vision. He was the one that really started a lot of the work that we've done on the Concrete Repair Code in the past 10 years. And as we give you a presentation overview, this presentation is talking about the standard of care, and it really goes back to a lot of conversations that we had in the ACI Rehabilitation Committee with another guy that's been around. As he used to say, he was a young guy just trying to get some experience, Jim Warner. And that was his line, a young guy trying to get some experience. And I don't know how old Jim is, but if he was practicing and started his contracting business well before I was born. But he's a great person if you ever want to talk to him. And we talked a lot about the need for the standard of care, specifically in the evaluation portion of existing concrete structures. And today, really what I want to talk about is some thoughts on what that standard of care actually may be. So some fundamental questions. How much evaluation is necessary? What are we doing? How many samples are we taking? Are we getting enough to capture the representative elements? Are we getting enough to capture the structural behavior? How much evaluation is possible? We just heard in the previous presentation, they couldn't get in to evaluate the structure. And Dave, that's one that you and I would probably may want to consider walking away from. So that's a real problem. What are the cost limitations? If there are significant cost limitations, can you satisfy a standard of care? Because as Avanti mentioned, you don't want to be having to answer questions about what you did. And how the standard of care, how can we ensure it's going to be met? These are some of the questions that we had a lot of discussions about for several years in ACI 364, and we've never come close to answering them. Just so you know, there's no answer at the end of this presentation. Going forward, what can we do to help engineers actually determine what the standard of care should be? I think the responsibility in concrete construction, the ACI 132 document, is going to be an important step forward. So, stepping back, these standards of care that are shown on the screen are from Gene Stevens, a member of the ACI 562 committee, who's a person that passionately argues about exactly what the standard of care should be. And it's really defined as a degree of care that a reasonable person should exercise, the quality of work by a professional engineer, and use of generally accepted standards, and for the engineer's work product to be safe. Those are all great definitions. They're all helpful. The question, though, is when we talk about an existing structure, and we'll talk about some of the challenges of existing structures as we go forward, how do we do that? So, generally accepted standards, ASTM, ACI, ASC guides. Note that that's guides. There is no one standard at this point from ACI that really defines what the standard of care should be. The ACI 562 is a standard code for repair of existing concrete structures, and it helps define the standard of care. But in terms of the evaluation process, it provides information, but there is no single statement in there that this is the standard of care. And the other one that is interesting is the Astro Bridge Inspection Manual. We're typically talking about concrete buildings, not bridges, but there's some concepts in there that I think are important in terms of what we need to consider when we're developing a standard of care. So, existing structures. The most important thing to remember about existing structures is they can be non-redundant. That's a critical concept. This is a flood control channel in Ventura County, California. And this is one of several similar structures that I've worked on over the years. And you can see this is where the section of the wall actually collapsed. This is a little bit of a service access way. This is a major roadway that serves the Port Hueneme naval base. It's heavily traveled by military vehicles going in and out, bringing supplies in and out to Port Hueneme. Failure occurred on the best possible side of the flood control channel. It didn't fail. If it failed here, the roadway would have been out. This actually occurred 2 days before Christmas. And why did it happen? It's a cantilever wall that's non-redundant, that had very concentrated microcell corrosion at a construction joint. For some reason, 30 years ago, actually more like 40 years ago, the standard of construction in California for flood control channels, and this is in a marine environment, was to not use an internal water stop inside the wall. There was no water stop here. There's no water stop here. Why? They probably saved about 30 cents a linear foot on the miles of flood control channels that they built in areas that go from marine environments all the way through up into agricultural areas to areas where it hasn't rained in 2 years, and I have no idea why you need a flood control channel. They saved 30 cents a linear foot 40 years ago. Now they're looking at a couple $billion problem. Why? They created a structure that's A, non-redundant, and B, highly subjected to corrosion. It's important, and I'll point this out. Looking at these walls, you would never see this corrosion until you did some probing in there. There's very little displacement of these walls prior to the actual failure. So, when you talk about existing structures, I'm not convinced that a perfect survey of an existing building is possible. I don't know that when I'm doing a condition survey, I ever get a complete sense of the extent of damage. The number of samples is never enough. But when we start thinking about it, when we start determining how many samples we should take, we need to think about the cost of the evaluation. We need to think about the redundancy of the structure. And are we getting all the representative elements sampled? And are we considering enough in our sampling the critical locations? I threw this slide in. This really belongs in the section that I'm going to talk about facade assessments. This is my new personal record as the largest piece of a building that I've taken off of a building during a facade survey. If you can see that piece of concrete, that's my foot. It's a pretty big sized chunk of concrete that was taken off of a building during a facade survey. We'll talk a little bit more about facade inspections. So we're talking about existing structures. Sometimes there's obvious conditions that this is a little bit of a precast shim pack that right on the edge. But that one was very obvious. It was easy to see. And there's the not so obvious conditions, hidden failures. At the end of the day, if we get a failure because of either of these two conditions, whether or not they're seen, we're going to be in that spot that Avanti talked about. Somebody's really questioning our judgment that we didn't capture something. So what do we do? Hidden damage. This is it's actually about 6 blocks from here. About 6 blocks from here. This is actually New Year's Eve. I was looking up this New Year's Eve 2015, and something was bugging me. There was a piece of this is a concrete column. And it was fireproof steel connection. They put a new steel connection into a concrete structure. And there was a crack in the fireproofing that was bugging me. I didn't like it. So I went up, I chipped out the fireproofing. And most people know when you have these 3 holes, typically there's bolts in them. There's the 3 bolts. They had all sheared. When they had sheared, I'm not sure. I have no idea. But really, there was a significant connection that really wasn't a connection. That honestly, I got lucky. It could have failed at some point, and I just got lucky to find it. So we don't want to be in that spot where Avanti was talking about, somebody questioning our judgment. Sometimes you do get lucky. So what are the standards that we have in the industry for actually doing some of these things? What can we use as standards to help develop this standard of care that we're talking about? Bridge inspection, bridge evaluation. National bridge inspection standards. A couple key points. Biennial inspection. Tactile inspection for fracture critical elements, or pins, or hangers. And typical supplement, per the National Bridge Inspection Standards, you're typically going to supplement some sort of NDT on these fracture critical elements. So those are some concepts. Timing to it, fracture critical, non-redundant pieces, you need to do more thinking. Building facades. ASTM E2270 is a guide standard for doing a building facade assessment. What does it have? Some critical pieces to it. Qualified personnel. That's important. Basically, as engineers, we're able to self-certify ourselves as qualified, but when we start thinking about having some subcontractors involved, some people that may be doing some access and rigging for us, are those people that we may have helping us qualified to look at it. There's two parts to this guide. There's the general inspection, visual, and the detailed inspection that's tactical, in which you're building upon the general inspection results. So we're looking, when we're talking about a typical building, we're looking at the facade. We're looking in these, we're generally looking at the things that may be falling down, may be coming loose, but typically these are used as part of local ordinances, where we're talking about doing facade inspections. New York City Local Law 11, Chicago ordinance, Philadelphia has an ordinance. We're talking about doing inspections on exposed elements, the street exposed facades. There's a requirement for reporting of unsafe conditions. Typically, if you read the ASTM, that says you have to, the ASTM will tell you have to work that out with the owner. Statement of water tightness, and some maintenance requirements. Talking about doing this with qualified personnel, this is a building that I'm working on, almost finished. It's in New York. This is an interior courtyard, so you wouldn't see this, you wouldn't typically do your facade inspection, but take a look at the slab edge. Notice that it settles out about 1.5 bricks. Now let me ask you a question. Do you think this window is going to be long-term watertight? These are the types of things that you may see, but the more interesting one, and this is new construction, this is a condition where there was a post-tensioning grout pocket that was popping. There's two questions I have there. First, is that grout pocket that's popping a potential hazard? And second, why is a post-tensioning grout pocket falling on a brand new building? So these are some of the types of things that you'll see and maybe have to understand the implications of when you're doing a facade inspection. There's also a requirement in the building inspection ASTM guideline for removal of unsafe conditions, and that's kind of the one that I question. I showed you that piece of concrete earlier. I'm not convinced that having an engineer remove unsafe conditions is the best idea, but it's an important thing to think about in terms of the completeness of the survey. You're expected as a design professional doing that facade survey to identify those conditions and help make them safe. So that's another couple of key pieces of our standard of care for evaluation of existing structures. And finally, since I am the chair of the committee, I may as well talk a little bit about what we did in ACI 562 to start establishing what the standard of care should be. And specifically, it's section 6.2, and we're talking about a performance-based code. Performance, not prescriptive. Evaluation is required. It's really when it's performance-based, so when there's evidence of distress and damage. Behavior inconsistent with design. What does that mean? I looked at that slab edge, I showed you that picture of that slab edge earlier. It sure as heck wasn't supposed to be a 2.5-inch deflection over 10 feet. That sure wasn't consistent with the design, but there was no distress associated with it. So I knew, through a couple figuring things out and looking at, there's no cracking, no distress. I knew that the guy screwed the formwork up. It was pretty obvious, but I needed to make sure of that because the behavior was inconsistent with the design. And you're going to do evaluation when there's some preliminary evaluation results that suggest you have a problem. What are you going to do with those evaluation results? And there's a couple more key pieces as part of our standard of care. Repetitive elements. If I notice that there's one, let's say a punching shear cracking around one column, and I know that I got a couple hundred of those, if I just have cracking at one, in terms of a standard of care, this is suggesting that it's not enough to just look at that one location. You have to think about repetitive elements. If you're designing repairs, maybe just doing one repair is not enough. And that's something that's important to communicate to your clients. The gentleman earlier says you need to communicate with your owner. That's important because it's not enough. Analysis, if you're actually doing it, in terms of a standard of care through an assessment, it really needs to be based upon the as-measured conditions. We need to understand what's going on with the structures, how much damage may be present, what alterations are there, and then do our analysis based upon that. So, some thoughts now on standard of care for existing structures. This is something I think as professionals in the room we need to work on to try and help define. This is it's not clearly delineated anywhere. This is really something that design professionals are doing on a project-specific basis. And the most important thing, if you can take something, I really think we need to stress when we're dealing with these, when we're working with an owner and trying to establish what our scope of our investigation is going to be, we need to think about the concept of completeness first, cost second. If the owner really wants to get somebody to do a low-cost survey, let them do it. It's not worth, as Amonte said, being on the other side of the table, having to explain why you didn't investigate something. But in terms of evaluation considerations, you always want to do not just tactile, but when necessary, invasive surveys. We need to get into these structures because there's always going to be things that we can't see until we start taking it apart. Our survey should be focused on inspection of non-redundant elements if they're present in the structure. I've done a lot of work on tied back walls in a complex in Oxnard, California. None of us involved in the survey were comfortable until we went through and actually started looking at some representative tiebacks. Actually, which was expensive because we had to dig a hole in somebody's backyard, remove a whole bunch of protection, but that was the only way we felt comfortable with the long-term behavior of those tiebacks. Why? It's a non-redundant, tension-critical element in a marine environment, and we had no idea how it was done originally. So we're considering the redundancy, the exposure conditions, because why? That's the only way we were going to feel comfortable with the results of the survey. And so those are my thoughts on the standard of care for existing structures. As we go forward and try and work on doing this a little bit more with 132, I think this is something we need to, I don't know if we can codify it, encapsulate it, but I think we need to reflect some of these things inside of a responsibility document when we get forward working on it. So finally, as I'm ending, just some acknowledgements, some great conversations over the year. ACI is a great place to learn stuff. Jim Warner, Gene Stevens, Dave, Randy Poston, Larry Kahn. These are some guys that have been great in terms of these types of discussions over the years. So I want to thank them.